Say we want to find derivative of product of two functions. So we want to find derivative of f times g, and we want to find its derivative. It's tempting to think that derivative of product equals to product of derivatives. Okay. So let's check if it works or not. Just let's pick an easy example. Pick both functions to be x, so x times x. We want to find this derivative. If I take derivative of x and multiply it by derivative of x, I will have 1 times 1, which is 1. On the other side, x times x is x squared. Derivative of x squared is 2x. So my answer should be 2x, which is definitely not 1. So what I conclude from here is derivative of product is not equals to product of derivatives. As we see here, because 2x is not equal to 1. So that is not the case. So please do not do this type of mistake. Alright, so now we'll try to learn how to take derivative of product. So we're going to get the product rule. Alright, so we want to take derivative of product. We're going to write down limit definition of derivative. That is add x plus h minus add x over h. So we're plugging in x plus h for x, plugging in x. So we get that expression. Now to figure out what is happening with this expression, I'm going to do a little bit of geometrical interpretation. So I'm going to write down draw the following rectangle. So let's say this one length is f of x. From here to here it's f of x plus h. Say up to here it's g of x, and from here to here it's g of x plus h. So the following picture. So whole area. So area of that big rectangle is f of x plus h and g of x plus h. Area of that smaller rectangle which is inside is f of x times g of x, because this length is f of x, this length is g of x. So f of x plus h times g of x plus h, which is whole area. Subtracting this piece, we get piece 1 plus piece 2 plus piece 3. So that 3 pieces will be left after we do subtraction. Okay, we have 3 pieces which are left. Okay, now let's figure out what is the area of each piece, and rewrite our limit. First piece, length is f of x, height is the whole thing, which is g of x plus h minus g of x. F is 1 plus, now 2, this length is f of x plus h minus f of x. Now its height is, as we did in the previous case, g of x plus h minus g of x, and we'll let this piece. That's piece 2. And similarly, piece 3 will be g of x times f of x plus h minus f of x. Hope you can read what is written there. So that's piece 3. So now I'm going to separate that integral into 3 pieces, and we we're going to see what is going to be happening. So limit as h approaching 0. Okay, so first piece over h. Plus, so I'm going to write down 3 different limits, plus this over that, plus piece over h. So I wrote now 3 limits, and now I'm going to look carefully at which limit and see what is going on. So if I carefully look at this expression, that is limit as h approaching 0, g of x plus h minus g of x. So that is derivative of g at x, and we keep f of x, plus, if I carefully look at this piece now, h approaching 0, f of x plus h minus f of x over h, and when h approaching 0, that is derivative of function f. And when h approaching 0, I get g of x minus g of x. Which is going to be 0. Plus, now carefully look at this piece, f of x plus h minus f of x over h, as h approaching 0 will be f prime x, and g of x stays as g of x. Right, so we got our answer as f of x, g prime x plus g of x, f prime x, because g of x minus g of x equals to 0. So we got our answer for the derivative of product. So derivative product of 2 functions equals I'm going to switch order. It's a common way to write in it. So derivative product equals product of first times second plus first times product of second. That is called the product. So please remember it and use it when you need to find the derivative of product of 2 functions. So let me illustrate 2 couple examples on how to use product. Say we want to take the derivative of x squared times sin x. I see product of 2 functions. So I see the first function x squared, I see second function sin x. So I'm going to be using my product rule. So my scheme for product rule is derivative first times second plus first times derivative second. So my first function is x squared. My second function is sin x. I recall that derivative of x squared is 2x. Keeping sin x as sin x. I recall that derivative of sin x is cosine x. And that will be my answer. So derivative of x squared sin x is 2x sin x plus x squared cosine x using that product rule. Let's try one more example. So if we want to take derivative of sine of x times cosine x. So again, I see product of 2 functions. So I'm going to be using product rule. So I'm going to write down the scheme for product rule. Derivative first times second plus first times derivative second. So I'm going to fill it up. First is sin x. Second is cosine x. Derivative of sine is cosine. sine x, and derivative of cosine is negative sine. Simplify that expression just to be cosine x times cosine x cosine squared, sine x times sine x, a minus in front, so minus sine x squared. So that's going to be fine.